Colócate donde tú te sientas cómodo.
Es que tampoco quiero estar aquí atrás mirando.
Colócate donde tú te sientas
Pues me
cómodo.
pondré a tu altura, o sea, con tus cojones.
Colócate donde tú te sientas cómodo. Aquí, en aquí. Estoy probando lo de random. ¿Sabes lo bueno de esta base? Que aquí controlas el tiempo. Vamos a
Ya, pero
empezar en 5 minutos, ¿vale? Les voy a
yo te...
dar un simple máximo para
Si llegas a la media hora te
un
sirve.
poco más fácil.
Se lo mata. En fin. Hay poquita gente, ¿eh? No hay mucha gente.
Pues Guachi, si quieres, nos sincronizamos y nos damos el start tú y yo, ¿vale?
Nos comemos como la hostia. Vale, genial, muy bien. Tiene un botón de prueba.
Es que...
No, no de contenido. Es esa dirección. No, pero no está al revés. Esto es así. Están los relojes aquí están
chicos, ¿queréis que quite el portátil y dejo el vuestro? ¿O preferís estar ahí?
Es que no llega el cable.
¿Queréis otra silla?
Bueno, sí, vamos a estar de pie todo el rato. Es
¿Sí?
solo para 4 minutos de una demo.
Decidme vosotros.
¿Quieres silla? ¿Quieres tu silla?
Va.
No. Prefiero bailar por aquí por la silla.
Haces muy bien, yo lo suelo hacer. Disfrazado de pato si hace falta.
Ya he visto la foto.
El año que viene algo tengo que hacer.
Es verdad que es aniversario ya.
Décimo.
Mira, a ver, algún bicho que tenga que ver con 10 y ya está.
Ya veremos, ya veremos.
A mí me parece buena idea la que planteaste.
Yo creo que el ciclo hay que... A ver cómo se lo gestionamos. A veces es difícil abandonar los proyectos.
Porque todo proyecto necesita un líder. No, pero está claro. Es que si no... Y no todo el mundo tiene una personalidad, y es verdad. Y los proyectos...
A lo mejor lo que tenemos que hacer no es salir, pero darle espacio a que lo organicen. O sea, yo una de las cosas que quiero hacer es ver si les voy a dar una vuelta más a los conejos el año que viene. Si todo va como tiene pinta, que tiene muy buena pinta, voy a proponer que sean ellos organización. Entonces, ya ves,
Más que...
o sea, nosotros obviamente si salimos el proyecto se morirá.
Estoy seguro que sí.
Pero yo no quiero que se muera, pero el proyecto no puede ser dependiente del estilo. Entonces es un mal proyecto.
Es que los conejos no tienen nada.
Primer año sala llena, segundo año, veremos a ver el año que viene.
No sé.
Ya, son
Bueno,
decisiones complicadas.
¿sala llena de quién? Eso sería otro tema que habría que ver.
Pero oye,
Ya, no.
esto que es un evento de la comunidad, en la comunidad está todo el mundo, Alfonso, no estamos solo los listos. O es de otra manera.
Es tan matizable todo.
Ya, esta conversación ya la he tenido a menudo. A ver qué hora es.
Tú me dirás cómo empezó la primera.
Sí, lo sé. Ya está. Guachi, yo tengo la sala más o menos debe haber 400 o 500 personas, ¿vale? O sea que vamos a empezar. Son un poquito, pero bueno. Venga, todos. Empezamos ya en la 25 y en la 19. Venga, adelante. Bueno, vamos a empezar.
So we'll start. I think we've given them enough leeway. I think all of you, or most of you, know Alfonso.
Está funcionando, era un vídeo grabado. Jorge.
So we have him and Alfonso. Alfonso and Jorge as well. Jorge is a giant in this field. So thank you so much. Please introduce yourselves anyway. At the end of the presentation, please stay in the room because there will be something else. Okay? There's cakes outside, but wait at the end. Good morning, everyone, and thank you for coming. There's very few of us in the room. Well, first of all, I would like to thank the organizers for giving us the opportunity to be here once more. I think it's the 5th or 6th time in a row. We'll tell you about this in a minute. A rather complicated thing. My name is Alfonso Muñoz, Mindcrypt in Twitter. You can look me up in the internet. And Jorge Cuadrado, Coque, is here with me today. I'm lucky enough to have Jorge as a member of my team. So do follow him and give him a lot of love, okay? So what is this talk about? Unlike many other talks that you might attend in cybersecurity conferences, the title is not self-explanatory. This is what we will talk about. GSM covered channels using special commands. In order to understand our presentation, we'll have to give you some context. How did we arrive here? The concepts we're dealing with, and what we will do just after the talk. So bear with us. And then benefits and drawbacks of this methodology. We'll have to wait and see whether we have a demo effect. A short disclaimer, quickly. We know that some of the things we have tested might make some people nervous. That is not what we intend to do. Okay, sponsors might get a little uneasy. In the presentation, we've done our best to pay attention to the details. This is a talk from our point of view. Any doubts you may have, you may get in touch, and let us hope we're not sent to jail. Anyway, what is the presentation about? We will talk about something called Phreaking. These are techniques that come from a time before hacking. This is about learning and understanding the operation of telephones of different sorts, telecommunication technologies, and the operation of telecommunication operators. This is a very brief presentation. We don't have time to go into the details. You probably know the story. This is the 50s, 60s, and 70s in the US. A lot of really clever researchers. We have Captain Crunch at the top and his famous whistle, 2600 Hertz. We've printed a few. These are whistles that we have printed ourselves, and we actually printed a giant one. This doesn't broadcast at that frequency, but anyway, it's very cool. Should I blow?
Bueno, esto no.
This is like a horn, but never mind. So quickly, as I say, there's been very relevant people working in this field, in the field of electronics, communications. We have Steve Jobs and Steve Wozniak. We even managed to sell some of their gadgets. Mr. Misnick, you know the story, I'm sure. And here I am, blowing with this whistle. Lots of anecdotes everywhere. Okay, so that was this is about what has been happening in Spain. We have the Hack Story project. Here you have the URL with some of the smartest people in this country. We have the apostles, who are very well known, just to illustrate the fact that there's very smart people that have been working on this for quite some time. The really exciting thing about our profession is finding out that the world goes well beyond the basics, okay? So after that very brief introduction, let us move into the topic itself. This is about 2 years old. We were interested in understanding as best as possible everything to do with mobile telephony and all the elements that are necessary in those networks in order to, in turn, understand the type of attacks that we could expect. I'm sure you've been reading the headlines. There's lots of projects focusing on electromagnetic emissions, all sorts of projects that have to do with the security of mobile telephony. Out of all the different attacks, there's lots of them. We could spend hours talking about them. There's two big families. We have attacks on SSS7. You might protect everything. You might have proper encryption, but still, you could expect attacks. Things could be intercepted. People could see your messages. Sometimes we forget that this is far more likely than anyone could think. And then we have this world, which is quite invisible for most people, in that mobile phones have software that goes beyond the operating system itself. That software is usually executed at different levels of permission. For example, everything to do with radio emissions. So someone might inject something into your mobile phone and steal things from you. So there's lots of attacks that we need to consider in detail in order to protect ourselves properly. And of course, I cannot leave this aside. Those of you who know better about this field, this is one of the earlier designs from 1998. This is a homemade system for secraphony, secret telephony. So everything comes from here. We want to understand all the elements. We want to understand how to protect telecommunications. And to be more specific, Jorge will tell you about the actual handset. We are not going to focus on the network, but on handsets. That's our focus. So as Alfonso was saying, the presentation relates to a number of conversations that we had some 2 years ago. We started talking about privacy, and we ended up discussing those things that we keep under control in our handsets. We realized that that was really difficult to define. Far from being an easy task, there's lots of things happening behind the scenes. So we came up with this crazy idea. How about we set up a mobile phone ourselves to see what we'll learn by assembling one of these handsets? So when setting it up, we were clear about the limitations. We wanted to keep it simple, something that could be replicated by people without any advanced knowledge of these technologies, and we wanted to make it functional, something that could be used in real life. So what you see on the screen is our first prototype. On the right hand side, it's got its own interface. It was fully functional. The only thing is that it had to be plugged into the network to an electricity supply, but it gave us quite a few clues regarding our ability to build a handset ourselves. So we identified what we wanted to achieve, and after some time we had a chat with our friends from Rooted. They offered financing so that we could continue with the project and make some progress. On the left hand side you see the second stage. I said before that we wanted to keep it simple, so we wanted to recycle some of the parts. Those things that could be harder to build by ordinary people, we wanted to keep them as simple as possible. The loudspeakers and the microphone are things you can buy anywhere. The battery is a power bank unit with a couple of modifications, but they're rather simple ones. We kept it really simple, to be honest. Here you can see a more refined model. This is not the latest version, but here you see a somewhat more complex interface with more functionality. You will see that underneath we have Unix. This is the Debian version of Raspberry Pi, which allows us to do development at the same level as with a conventional computer, with the added benefit of being able to control things at the same level as you would control them using a computer. Another interesting thing is the size. This is more or less like a smartphone, but it's a bit thicker, okay? It's much bulkier. Take a look at the casing. We thought this would be a major challenge, but if you want to build your own models using 3D printing, there are interesting editors out there. I would encourage you to give it a go, because you will be in for a surprise. As I was saying at the beginning, this was the start of the research that we are presenting here today. But obviously, we wouldn't. We would like to see this as a beginning, really, as a starting point. We want to continue with this, and if any of you is interested, if anyone is willing to lend us a hand in helping us build a mobile phone which is more transparent, we'll give you our contact details so that you can collaborate with us. In case this is not clear, we are starting a project to create a free mobile phone. Roman has forbidden me to use the word bomb. It looks like a bomb, but it is a telephone, I can assure you. We haven't made any attempts to reduce the size of this handset. So if you don't like it, the casing can be removed. The original components are there. And as I said, you can print it with a 3D printer. So we're showing it to prove that this is real, okay? It is not a theory. That is a very brief introduction, okay? So let us go into the main purpose for this presentation. With all the knowledge that we gathered by building this handset, and with everything we knew beforehand, and everything we studied on hacking, we're not particularly interested in hacking mobile telephony networks to have free telephony. That doesn't make any sense anymore. There are good operators, there are good professionals working at very reasonable prices. Today, it doesn't make any sense anymore. What does make sense, however, is to study anonymity and privacy. We wanted to hide ourselves from the mainstream system. There's a lack of privacy, which is very clear in mobile telephony. So that was the initial point we had in mind. So we will set up covered channels using the GSM network without acting on the network itself. So we wanted to find out whether this is feasible. We wanted to focus on the possibility of sending small chunks of information. This is not about sending people episodes for Game of Thrones, far from it. We want to send, as I say, small chunks of information. They may be small, but they may be useful. An IP address, a Tor address, a Bitcoin address, whatever. Things that can be useful for someone getting the information on the other side. We don't have that much time to talk about covered channels in detail. If you have any doubts, please get in touch. So let us focus on the main subject for the talk. Everything you're about to see, we'll have a couple of demos, hopefully without the demo effect. So this is the structure. Here we have the GSM network. We don't care about the operator. We have tested this with all operators in Spain. What we will focus is the emission side and the reception side. For this, we will use the antenna, the aerial that we have used in our mobile telephone. We will try to produce changes through the antenna, through AT commands, by interacting directly with the antenna, so that by working with standard protocols for the interface, we can find out whether there is a way to introduce a change in the emitter and make the GSM network transmit that change to the receiver. So for us, the GSM network is a black box, basically. So we'll stick to the standards, and if we manage to find out something that affects the receiver, perfect, because that will be a covered channel as such. By the way, you can use any SIM card of any sort. You could use your own SIM card. We can make this as friendly or as hostile as we want, but obviously we want to be anonymous, as anonymous as possible. We've used anonymous SIM cards, And we're hoping to prove that it is possible to send information for free from the emitter to the receiver. That's why it's called p-hacking. So you can send information from one location to another using the GSM network without paying a single penny. Okay, hitting the headlines. That's not our objective. Okay, our objective, our real objective, is to remain anonymous. So details. As Alfonso was saying, in our research, we are dealing with the network as a black box, and we're focusing on the interfaces. So what are the elements in the interface? On the one hand, we have SIM cards that Alfonso will mention in a minute in detail, and then we have the GSM system itself. In this case, we're using this GSM module. This integrates this chipset. Why have we selected this model? Because of the bands. There's 850, 900, 1800 and 1900 megahertz. Those frequencies allow us to use this handset in basically any country in the world. How do we keep the handset under control? The control uses AT commands. These are commands for serial devices, rather standard commands. And in this case, we're talking about GSM 0707 and 0705, plus another specific one from SIMCOM. With these AT commands, we will be able to have all the functionalities in the GSM module. So the GSM module will allow us to make calls, send text messages, send multimedia messages. Using our GPS, we're connecting to the internet. This is a highly functional module. We have only implemented functionality for phone calls, but the module offers all the others. Okay, so it's highly flexible for any type of project. One of the things that people usually overlook is the range of operating temperatures. The module can operate at any temperature between -40 and +85 degrees Celsius. That means we could use this module outdoors if it is properly insulated, and that gives us additional benefits in terms of development. Last but not least, the price. You can buy this module in Amazon for 25 euros, so anyone can afford it really. On the other hand, we have the SIM card. We'll tell you about the price for the whole thing during the demo. The SIM card, very quickly. I am aware of the fact that this is a sensitive issue. You know that in Spain since 2007, because of our existing legislation, you cannot buy anonymous SIM cards. Unfortunately, today it's quite easy to get hold of one. We will not tell you how to get hold of an anonymous SIM card, but there's many ways to do that. So as I say, I will not give you any details, but it would be enough to say that if you want to make this more anonymous, you can use anonymous SIM cards. In fact, in many of our tests, we have used anonymous SIM cards. These are examples of anonymous SIM cards from other countries. Okay, not from Spain, from other countries. Okay, I want to make that absolutely clear. These are from London. Let's leave it there. Okay, on that note, now that we have seen the interface, why do we want to focus on the interface, by the way? Why do we want to focus on the gadget itself and not on the network? What we have seen in recent years is that traditionally, many devices have been secured based on people not having access to the hardware. Not easy to interact with that hardware. It is either very expensive or it's very difficult to get hold of, or both things at the same time. In recent years, however, we've seen a democratization of hardware. Suddenly, it is much cheaper or much easier to get hold of devices which in the past were very difficult to obtain. The module in Amazon is 25 euros and it will take a week. 10 years ago, I wonder how easy it was. It was probably much harder. So we have realized that in many systems, the security rules are not valid. Not anymore. They have changed. So since we have the GSM antennas, we wanted to know what we could do with them. Introducing information to try and send packages of data through a covered channel. So what rules did we apply to our research? Take a look at that tweet in the corner, which is quite descriptive. We took the manual for our module and we audited commands one by one. We wanted to find out to what extent the operator trusts us. The operator validates the data that we send to them. Do the data that we send arrive in the same shape to the receiver? What happens in between? Those are the questions that we posed. If you could speed up. This is the document for our GSM module. This is the manual that gives us all the guidelines on the commands that can be used for that GSM module. We're running out of time. Keep moving. Not everything is funny or amusing. There's lots of things, lots of details, lots of things highlighted. So this is the summary of the things we are taking into account. At the top you see the commands that we are using. At the bottom, those commands which we're not using but which we believe are very interesting. Let me start by the ones we're using, ATD and ATH. These commands allow us to place a phone call and hang up. AT plus clip will show the metadata for the phone call to the handset, activating it. It may be the emitter or the receiver. Then we have the AT plus clear, which allows us not to show the metadata, although the previous command might be activated, and the AT plus mooring. When the phone call reaches the destination, we may know through a message that the network will send us. With all of these commands, we will be able to set up a simple communication flow. Okay, just four commands. I'll go back to this, but let me tell you about the other ones. These ones we're not using, but we believe they're very interesting. In our context, they're not useful, but in other contexts, they may be. For example, we have the AT plus VTS, the second command, which will allow us to generate DTMF tones. We haven't used that because we would need to place a phone call, and the main purpose was not to pay any money for those phone calls. We have the AT plus accent saw, which will allow us to get error codes for standards implemented by the vendor, the module vendor. In our case, our module is rather standard, but in others, things may change. So talking about the other commands, Jorge, please speed up. This is the metadata that we could get from any phone call. The phone call, depending on the way it is terminated, will produce a number of codes. Here we would have 2 bits. In our demos, we haven't used this. You have 2 bits just by hanging up. We need to manipulate the way we terminate the phone call. In terms of time, that doesn't pay off. And then in these 2 data sheets, we see what is happening in GSM. We were assuming that lots of data will get to the receiver, and yet most data is intercepted halfway through or is treated locally. So there's very few data we could get hold of and move on. Okay, so we'll start with the demos. We're running out of time very quickly. Let us show you this demo as part of a video because it takes a while, and we'll do it in real terms here, and let's hope it works. The one we're about to see, out of all the commands that we have discovered, this is the simplest one, but the most stable approach. This is a summary. We will be using missed calls and a hidden number. We automate this and set up a coding system. If we want to send bit 1, we make a number call, missed call with hidden number, or missed call with visible number. Those numbers, by the way, are fake numbers in case someone wants to do something with these. The system is what you see there. Total cost 60 euros plus a cardboard box. It's basically the GSM antenna, which is 20, and an Arduino device, which is 20, 60 euros in total. So you set up the call, you hang up, you get the information, and there it goes. Let me show you the video. Take a look at the audio. When you hear that sound, it's like a missed call. If you take a look at on the left-hand side, we have the receiver. On the right, we have the emitter. You hear Jorge making some coffee in the background, but never mind that. We got bored with this demo. There it goes, that's the coffee thing. But if you count the time between different signals, that's 7 seconds on average. A missed call should be something instantaneous, but then there are network delays. For the receiver to get it in a stable manner, we're talking about 7 seconds in between. Okay? The fact is we've done this in several locations and it works. So nothing else. This is all the setup. You use the SIM card of your liking. Here we're sending 91 bits off the top of my head for router 2018. This takes about 10 minutes. Okay, so we'll skip the details. Okay, we'll move on. Questions you may have. How much information can be sent and how stable this is? Of all the techniques we have used, the best speed is this one. 10, 11, 12 bits per minute. We haven't included all variants because you can combine different techniques. In the worst case scenario, this can be improved. In the worst case scenario, with that investment, 60 euros, we will be talking about 12 bits per minute. And the question would be, what can you do with 12 bits per minute? Is that useful in any way? Is that completely useless? Is that just one more technique to set up a covered channel? Well, there's a number of things we would like to mention about that. 12 bits per minute means that in 3 minutes you can send an IP address, which is cool because you can use a server with information, you can send an IP address and you connect to the server. You could send GPS coordinates, a total address, whatever. If we're not just talking about 1 minute, because we're not in a hurry, in an hour we will be able to send 720 bits, which is enough to do interesting things. If we talked about 1 day, we might be able to send images at a reasonable resolution, so it's interesting. The question you might have in your mind right now is, how stable is this setup? If it's only a minute, it's not good enough. The thing is that it should be stable enough for it to last for an hour or for a day. In the last 5 months, okay, we've been doing tests for the last 5 months. None of the SIM cards we've used, and I can tell you we've used a large number of them, none of those SIM cards has been blocked, ever. We will not tell you about what the operator does. We have no idea, actually, about the way they manage things, but SIM cards were not blocked. During these 5 months, we've done tests for about an hour a day. Okay, that's 720 bits. And as I say, no SIM cards have ever been blocked.
So we managed to send information for 2 days. So there were like some 34,560 lost calls. So we just stopped that because it was just a proof of concept and we just didn't want to bother anyone, and we don't know how telecom operator manages that. So our objective is to make it stable in an hour. And we proved that. So therefore, the research, and the hypothesis had been verified. And what have we done ever since? Well, we've been working on amplification techniques. That is to say, to send out more information over a shorter period of time. I may not be wanting to be there for an hour, and I just don't want to use SIM card for such a long time. So amplification techniques. We've been doing some research. We are doing some other research right now as well. So we've been working on 2G. We just don't need to work on the internet. 2G is enough. We show you a demo. We are using virtual numbers to make the system cheaper, and then we have some time. So we will make a demo mixing 2G and the internet so that you can take it home with you and try it over there. So let us move on to virtual numbers now. So in covered channel, we are interested in capability. Once we have developed these base methods, then we moved on to finding out how to amplify that. So for that, the first thing that comes to mind is, well, if you have an antenna, a SIM card sending out information, why not using 10 of them? Therefore, you will be sending information 10 times, okay, if nothing prevents you from doing that. So, well, we continued researching, and then we found virtual numbers. And at the time, I didn't know what virtual numbers were. Virtual numbers, well, in this case, we used telecom companies that in a free manner and potentially anonymous give you this type of numbers. How does a virtual number work? Well, at least the use that you make is the following. You call that virtual number, and that number redirects the call, forwards the call to another number. What did we do for that? So in our case, we took 16 virtual numbers. Each number represents a binary value of 4 bits. So since from the emitter, we make a call to one of those virtual numbers. The virtual number will send the call to the receiver. So we are amplifying by 4 the number of information that we are sending out. One of very interesting characteristic of this is that if we are using virtual numbers, therefore anonymous, we will be detaching, decoupling the receiver from the emitter. So therefore the receiver wouldn't know about who is the actual emitter, which is very important for anonymity. And the other way around, we could also do this anonymity between the receiver and the emitter, which could be very interesting in some scenarios. So in this case, transmission is 28 bits per minute, taking into account 7 calls per minute, which is much better. Okay, so now we move on to a live demo. So the summary is the following. Because we are very hand-tight, we just don't want to spend lots of money in antennas, so we either use virtual numbers, which are free numbers. There are many companies offering that, or you pay for them, and each virtual number was like 2 or 3 euros. Okay, well, if you pay for them, you have to give your credit card number, but that's as much as you have to provide. Okay, so we have a video, probably will fail. Okay, therefore let us try to do a live demo. It is more complex, and that's why we wanted to show it to you. The previous demo was simpler, but this one we will just see the virtual numbers. So we have problems with these cheap electronics, these cables which are also low quality, also the telecom operator in between that will give us some delay and problems of coverage as well. But anyway, I'll tell you what we will do. We will be using Arduino, and we will send out the protocol. So we have the 2 antennas for the receiver and from the emitter. And then if everything goes right, I don't know whether everything will go right or not, it takes 3 minutes. We will just use a very hacking music, okay, so that you, so that it is friendlier to follow. Please, okay, if it works, give us a big round of applause, because we are not sure whether it will work or not, okay? Okay. So by the time we've seen that at least 2 blocks have been sent out, okay, we will play the music. Not before that. We just don't want to go into coitus interruptus. So it takes some time to launch the information. It takes like 20 seconds to connect to the network. Okay, worst case scenario, taking 20 seconds to connect. Okay, shall I play the music? Even no. We wait. Oh, I'm frightened. Okay, I risk it. Okay, if it works, we'll be over the moon. All right, we have sent out the first 4 bits. Okay, the first CK. Okay, if it sends out and does not receive a CK, you cannot launch anything. Oh no, it's working. Well, basically, I am anticipating that we will be sending 32 bits with only 8 lost calls. You could do that with your ordinary SIM card. We are using the technique of amplifying virtual numbers. Okay, so on the right we have the receiver, on the left we have the emitter. And we will tell you why it takes longer than the video we showed before. Well, here we depend on very many factors. Well, it is the most complex, the most complicated, but we just wanted to show it to you, okay? The other one works and it was not very exciting just because of that. So we tested it this morning 6 or 7 times, and then, well, to be honest, it only worked half of the times. How are we doing with time, Roman? Want to try it again if it doesn't work? Okay, video. Well, some coverage has been lost. Okay. It's disconnected from the network. Okay, this is the module. The module has been disconnected, but we just wanted you to see the flow. Okay. Well, basically what you do, well, virtual numbers are amplified by 4, and you receive the same protocol that we mentioned before. If you don't have any network connectivity issues, then this is what happens. And then let us move on to the end. So in this demo, we have sent out 32 bits by making 8 lost calls. We could have coded anything, but we decided to code a shortener, which is rooted 2018. Yeah, rooted 18. So basically, this takes us to a Tor hidden service. with mechanisms such as this one or such as the previous one. If we are ready to wait for longer, we will not be depending on a third party, and we could send out whatever we want to send out. It's just a question of time, of waiting. So, well, we just had this rent a hacker thing, that this is the information that we sent out. So the concept is clear, which is the purpose of this presentation. And now well, we are about to finish. We move on to another demo, and we also want to share with you other amplification techniques. In 2Gs, you need to find a way to do it through virtual numbers to send out as much more information per minute, okay? To run the risk that the more parties of things you have in between, well, the more likely you are to fail. But if you just don't mind to use the internet, well, you could just use or do other type of systems. Well, I'm sure that you are aware of some services and devices on the internet that can help you make calls. So if you use shorthand, you can find lots of services, free services and free calls. That is relatively easy. You can do coding systems. And in the next demo, we have focused on something that any of you could do. That is to say, well, using the spoofing of the caller ID. So we will be using the capacity to modify, to change the name of the caller. Well, I'm sure that many of you are aware of this. This is possible. Many internet services allow you to do that. We will be using that capability not only to use the caller ID that we want, but also to have a covered channel. So if you make this quick calculation, notice, if you could just modify the caller ID, which is often made up of 9 digits, in an ideal world where all the numbers will be valid, we would be able to hide 9 bits. So that means that one lost call will be enough to send out 29 bits of information. So, for instance, an IP address. So it is quite interesting. And to finish off, okay, we move on to a demo to see how we can use this hybrid system, 2G, doing caller ID spoofing. I will be coding a URL with a lost call. And this is what I will be sending out. That URL will come with some hidden information. What URL want to use? Well, there are many of them out there. We will be using any URL that allows us to introduce a parameter, to fill that parameter with whatever we want to fill it with, and by the time the server will be run, nothing will go wrong. It will take it as valid. Well, there are many websites, many places where you can do this, not to harm anyone. We have just used Google, okay? You just take the parameter, you introduce it to Google, and then we have added some encrypted information here. I'm going to generate a small shortener. Okay, I hope I will get it right. I hope it is not taken. I hope I'm lucky enough. And it is free. Oh yeah, this one is free. So what we just did, we just developed this program that shifts a URL into a phone number. So to ZS, okay, see if it works. So the shortener is to ZS, and I did some magic and I turned those bits into a telephone number. So I have that number that will be the caller number, calling number, and then I need something that allows me to do the caller ID spoofing. And for that we will be using quite a turbid system, which is lostcalls.com. There are very many of them on the internet. We are showing this one just in case you just want to take a look at. It is a turbid place, so a blurred place. Okay, so this is the caller number, and then well, imagine that this is my telephone. This is not my telephone number, okay? Because you are hackers, okay? So this is a virtual number pointing at my actual number. This is the captcha. You know that this captcha can be easily broken. So this thing that can be automated, well, anyway, we want to show it to you manually so that you see that it's not difficult. So the difficult thing here is just to introduce the right captcha. You see, wrong code. Okay, we just copy the virtual number. Okay, this is very quick. QRRI J6. Oh, that was not the number. Oh. Okay. If it wants, it will make a call. Oh, can you see it? You cannot see it. Not at all, isn't it? Can you see the number? Oh. Do you like this one? Well, if you like that one, I can choose that one. Okay, I'm ready at your disposal. Okay, I'm here for you. Okay, I will make another call. You know that this is expensive. Okay. Call again. Let's call. Did I? Imagine that I don't get a call. Can you see it? Okay, that's the number. Wonderful. So now the idea is once we have that number, well, it is trusted, it is that very same number, so we just need a tool to recover information from that number. URL, then we introduce the number. Mobile number, this is the number on top. Okay, this is not fake, okay? And this is the following. So it has recovered the information that we sent out. No mystery there. So these techniques will help us send out up to 29 bits per lost call. Well, just to mix it, to use it together with the internet, we have sent out this shortener. So this connects to Google, and then we recovered that parameter. And the parameter that we have chosen for this demo, I hope the keyboard works. Okay, so what we have introduced in that parameter is an ID or IP address, a hidden service from Tor, latitude, a telephone number, a big enough message. So, well, by making combination and through a lost call, you can just send out whatever you want to send out. So it is very easy to do, very, very easy. All right, so we are nearly finishing. So, summary of all this. So, we'd like to say that thanks to the lower prices of hardening, it is possible, or hardware, it is possible to make this type of research. Well, the demo that we showed you is very stable, but it's a bit slow. If you don't have time issues, you can send out quite a lot of information over an hour or over a day, and to send out specific things, well, this is wonderful. If you want to complicate your life, well, you can try amplification techniques, and if you are not that much interested, you just want to achieve your objective, you just use internet services and then use a mobile phone as an alternative channel to make it a bit more complicated. Well, the full investment, the whole investment for all this is around 60 euros, so I guess that anyone can afford it. So this is all from us. So I hope that you find it at least interesting. Any questions that you may have, we are just reachable on those addresses, okay? Thank you very much. Well, I think Roman wants to make a draw. So I would like to highlight that these are the components. This is a casing. We made a casing with 3D printers. So it is a bit long, but we just decided to make it long. If you don't like it, well, you can just open it and reuse the components, the different parts. So the greatest challenge here is that we didn't find many projects on the internet. Well, actually the projects that we found on the internet to create your own mobile phone, we just tried them, we just didn't, but they are not working. But it was most time consuming. Can you see it now? Oh, it's upside down. So what I wanted to tell you is that out of all the projects on the internet, the main problem was the battery. So the battery issue was not resolved. Okay, we just wanted to have a autonomous standalone battery, and now we want to move on to fix to have like better microphone and better speakers. Okay, we are using low cost speakers. Okay, and well, we will continue to improve it. So there is only one trick. So there are 3 boxes here. One is operational and the other 2 are just to be set up. Okay, so well, let us see. Okay, so only one of them is set up. Okay. So we have opened a random.org, which is the most democratic, and that is redirected to the local host so that I pick on the winner. No. So, well, the number of people that have confirmed is 1,825. We are extremely happy with the number of participants this year. This is... Oh, I closed it. I am just so stupid. Give me a minute. Well, for instance, I don't know, we can pick like unusual family numbers, such as Gonzalez.
Perdóname un segundo que lo voy a hacer en online porque es que...
Okay, give me a sec, I will do that online.
Con uno con cada caja, ¿sí? Y ya está. ¿O los quieres?
No sé, no sé.
Disculpad, es que para llegar a la lista de los códigos tengo que...
Apologies, to get to the list of codes, I have to connect to another network and well authenticated there, so give me a sec. Bear with me.
Lo cogemos. Sí, por favor, si alguien está interesado en el proyecto este de teléfonos móviles.
If someone is interested in these mobile phone projects, we just want to build a community, and then we want to publish as soon as possible or soon the steps to follow for that. Okay, we are ready. Okay, let us generate random to see who's the winner because we have the 3 rooms. Perhaps the person is not physically present at this room. Okay, we will generate the number. Okay, so we'll click on the generate. So 1804, 1804. Roman, no, it's not me. So who's going to see unique ID? Okay, you may come down if you so wish. Oh, you have cut off our demo just for this? Oh, Alfonso, you will not come back. I will not invite you back. Oh, apologies for this disaster. Okay, so if you don't get it right now, okay, we will leave it for later. Okay, Jose Antonio Maldonado, do we have a Jose Antonio Maldonado in the room? Oh, good, it stands up, wonderful, we have a winner. Okay, we just give him the setup one, the right one. Okay, I get. Okay, photograph, please. Okay, yeah, photograph like politicians. Okay, give me a smile. Thank you so much. Okay, let us move on to the next 2 ones. Okay, tomorrow we will be giving away the other 2 ones. Okay, these ones are unmounted. All right, so thank you very much for your attention. Oh, sorry, we didn't open the question and answer session. Okay, who's got a question? Oh yeah, I forgot about questions as well. Just a quick question. Do you think that that work or the future evolution of this work could have an impact legally in terms, in terms of regulation for GSMs and telecom operators? No, I don't think so, because we are abiding by norms or regulations, and well, the most basic mechanism that we use is a lost call. If you make it hostile, well, operators will just see whether you are moving away from the regulation or not, and they will block your SIM. But as I showed you in the last demo, you only need 8 lost calls to send out information. Well, I have people who are all the time terminating or hanging up their calls, okay, for me to call them back. So, well, if you want to send out an IP address, that's not a problem. If you are hostile, well, the telecom operator could just block your SIM cards. You are just not taking advantage of any failure, of any vulnerability. So that's because you are just taking advantage of connectivity or the way network work. All right, so 2 more questions in the room. Okay, good morning.
Very well done. Quite a curious piece of work. I guess it can be striking for operators. They might realize there's a large number of missed calls, not hiding the number. If the operator pays attention, they might focus on this. And in the first case, it would be quite easy to get hold of the information that is sent, unless you are encrypting it. Well, yeah, this is like any other covered channel, basically. If the operator sees that there's something odd happening in the network, they might look into it. Would there be a way to encrypt the information? Well, we're focusing on the covered channel. Encryption is taken for granted. That doesn't make any difference. You encrypt the information, but that doesn't add any complexity. The interesting part here is that the SIM, we were expecting they would block the SIM, and that's why we used anonymous SIM cards. But then we realized that nothing happens. Many of the tests were conducted using my own SIM card with my name related to it. Thank you so much.